Hi, good morning. So for today's video, we are going to discuss parabola, and I am your teacher for this video. I'm Sir Paul Joral R. Santos, and I'm part of the Senior High School Department of the Marinas Integrated High School. For our first uh, objective, you should be able to define a parabola. Second is to determine the standard form of equation of a parabola. And third, we have to graph a parabola in a rectangular coordinate system. So here we have the definition of a parabola. Say, let us have a line D and a, a point F not in D, meaning to say it does not lie on line D. Now, we have here the definition of the parabola as a parabola is the locus of points P whose distance from F or from point F and line D are the same or are equal. The point F is called the focus and line D is called the directrix. Now, as you can see here, we have here, the parabola. As you can see, that one is the parabola. And we also have here the point F, which is the focus, and line D, which is the directrix. Take note that a line D is different from line or point D, yung may capital letter. And aside from that, uh, the definition tells us that this distance D sub 1 here from F to P is, okay, wait for a while, no? Yan. This distance F here, or from F to P, we have here D sub 1 is equal to D sub 2. Okay, that is what the definition tells us. Now, if we have another point P somewhere in between V and this point, existing point P, no, its distance from F and its distance from the line D is the same. Now, we also have here the derivation of the formula for the uh, parabola that opens upward. Now, we have here V with the coordinate HK be a point on the parabola. Okay, we also call this point V as the vertex. Whose distance A, okay, take note that this A is not a preposition, this is a variable A. From the focus, okay, it only tells us that from the focus to the vertex, its distance is at minimum. And from the vertex to the directrix, the distance is also at minimum. And we label, or I label it as A. Now, we also have here point F. Its coordinate its, or this point F is also called the focus, no? And its coordinate H, or its coordinate is H K plus A. They have the same abscissa because, or V and F have the same abscissa because they lie on the same vertical line. Now, however, K plus A is the ordinate of F because it is higher, quite higher, A units higher than the vertex in this case. Now, we also have your point P rather, be a point on the parabola, no? And this point P has the coordinate x and y, or xy rather. Now, we also have your line D, or and on this line D, which is our directrix, we have a point D, capital letter. They have the same abscissa as P because they lie on the same vertical line. However, its coordinate is, or ordinate is K minus A because it is A units lower than the vertex. Now, in this case, the definition tells us that d sub 1 is equal to d sub 2. Using the distance formula, okay, the distance between F and P, or yes, F and P, um, X minus H obtained from getting the difference between the abscissas of P and F. And then the difference will be squared because the distance formula, or because of the distance formula, no? And then we will add it to the difference of y and k plus a in this case. For the ordinate, we are going to subtract also the ordinate. And then the difference will be squared. And same goes with, or same goes to the d sub 2. D sub 2 is the distance between P and D. As you can see, they have the same abscissa. So that will be, as you can see here, we have x minus x. And its, or their coordinate or ordinates are y and k minus a. So we are just going to subtract those two. No? After doing so, as you can see, okay, the next one is we have here, I just equate those two because the definition tells us that d sub 1 is equal to d sub 2. Now, yan. Parehas lang sila, no? What I mean is, uh, yung d sub 1 nilagay ko lang sa kaliwa and yung d sub 2 ay nilagay ko lang dun sa kanan. Now, squaring both sides will lead us to just removing the radical symbol. And then simplifying x minus x, it will give us x squared. And simplifying y minus the sum of k plus a will give us y minus k minus a. And for on the right side, we have y minus k plus a because negative multiplied by negative, it will be positive. Doing so, we have this. And afterwards, we are going to square this y minus k minus a. We also going to get the square of y minus k plus a. In doing so, we have this. Okay, y squared plus k squared plus a squared. They have both the, or both of the, both sides of the equation have these terms, no? Because we just square the first, second, and third terms. Now, here we have negative 2ky as a result of multiplying negative k and y. Also, on the right side, we also have that term. Actually, since those, or these four terms, the y squared, k squared, a squared minus 2ky are both present on the left side and on the right side of the equation, we can just cancel it out. So canceling this out, it will lead us to this one. So the only, or the terms that remain on the left and on the right are negative 2ay plus 2ak is equal to 2ay minus 2ak. And then after doing so, we are just going to move or add both sides by 2ay and subtract both sides by 2ak. In doing so, we have this. Okay. In other words, your teacher in junior high school called it transpose. Negative 2ay was transposed to the right, and positive 2ak was transposed to the left, or to the right also. So we also change their signs due to this process. Now, 2ay plus 2ay will give us 4ay, and negative 2ak minus 2ak will give us negative 4ak. And then factoring out 4a will give us this equation, or the standard equation of a parabola that opens upward with vertex at hk. Now, let V with the coordinate hk be the vertex of a parabola. The standard form of the equation of a parabola that opens upward is this one. For downward, we have this. Take note that the only difference between the first and the second equation is the sign of 4a. For the first one, for the upward, uh, for the parabola that opens upward, we have positive 4a, while for the downward, we have negative 4a. Now, take note the difference between the parabola that opens upward and downward and the parabola that opens to the right and to the left. Now, in this case, for upward and downward, the terms with an exponent 2, or the terms that was or that is squared is x minus h. While for to the right and to the left, the terms with exponent 2 is the y minus k. Okay? We also, or we can also say that we just interchange the position of x minus h and y minus k in the parabola that opens to the right and to the left. Okay, we also have to take note that the parabola that opens to the right has a positive coefficient, or 4a, positive 4a, and to the left naman is negative 4a. Now, when h and k is located at 0, 0, okay, the parabola or the standard form of the equation of a parabola that opens upward is x squared is equal to 4ay. For downward, we have this x squared equals negative 4ay. To the right is y squared equals 4ax. And to the left is y squared equals negative 4ax. Okay? Now, you should recognize these, or yes, you should be able to recognize if the parabola opens to the left, opens to the right, opens upward, or opens downward using this pattern. No? At first, if you are given, or let us just say you're given with an equation, you can tell by that equation if it opens upward, to the left, to the right, or if it opens downward. And you must be able to identify its center. Now, going back, or let us have the first example. In this example, you have to determine the focus, the directrix of the parabola with the given equation. You also have to sketch the graph and indicate the focus, directrix, vertex, axis of symmetry, and latus rectum. We have here x squared equals 8y for the first example, and for the second example, we have y squared equals negative 4x. Now, you have to determine the focus and the directrix of the parabola. As I have said, no? For the first one, we have x squared equals 8y. Now, how to determine the focus of the parabola, or the coordinates of the focus? First, by observing, we can deduce that the equation represents a parabola that opens upward. Okay, x squared equals 8y is on the form that the parabola opens upward. And as you can see here, 8 is positive. Hence, since 8 is positive, the parabola opens upward. No? We also have to take note that its vertex is at 0, 0. Okay? Now, let V with the coordinate HK be the vertex of the parabola. The coordinates of the focus F is given by, okay, we have here we have the number 1 if the parabola opens upward. For number 2 opens downward. For number 3 opens to the right, and for number 4 opens to the left. Since a while ago I told you that the parabola opens upward, we are going to use the first one. Now, before we use the first one, we should be aware that 4a is equal to 8 because we do not know yet the value of a. So 4a is equal to 8. Now, divide both sides by 4, it will give us a is equal to 2. Now, since a is equal to 2, we just need to replace h, k, and a by 0, 0, and 2 respectively. Doing so, we have the focus at yan, This is the substitution part, no? Okay. F has the coordinate now at 0, 2, or the coordinate of F or of the focus is at 0, 2, because 0 is the value of H, 0 is the value of K plus A, which is 2, it will give us 0, 2. Now, for the directrix, by the way, I just write it on the upper portion, no, so that we cannot forget the focus or the coordinates of the focus or the coordinate of the focus. We have now the directrix or the equation of the directrix. Let V with coordinate HK be the vertex of the parabola. The equation of the directrix is given by, now I have here four choices or four formulas, no, for equations, but we are going to use the first one because the parabola opens upward. Now, since the parabola opens upward, hence we have the equation of the directrix as y equals k minus a. And we know that k here is 0 and a here is 2. So we have y equals 0 minus 2 or y equals negative 2. Okay? Now, y equals negative 2 as the directrix. For the axis of symmetry, an axis of symmetry is a line that contains the vertex and the focus of the parabola. Its equation is given by x equals h if the parabola opens upward or downward. So they have the same formula if the parabola opens upward or downward. And for the parabola that opens to the left or to the right, we have here y equals k. Now, since the parabola opens upward, we are going to use the first equation. Okay? X equals h. And we all know that h is equal to 0. So this will be x equals 0. Now, I just write it there, no? X equals 0 as the axis of symmetry. Let us now define a latus rectum. What is a latus rectum? Latus rectum is a line segment perpendicular to the axis of symmetry. Okay? And that's the first condition. It is perpendicular to the axis of symmetry. It passes through the focus. And its endpoints or whose endpoints are on the parabola. Okay? The length of the latus rectum is given by 4a and its endpoints are on. Now, as I have said, we will just look at the first pair, no? Because the parabola opens upward. Since the parabola opens upward, we have this equation. And then by substitution, we have h was replaced by 0 plus 2 times a was replaced by 2 and k plus a is just 0 plus 2. And same goes with the other or for the second one, but the operation between h and 2a here is subtraction. Now simplifying this two, it will give us 4, 2 and negative 4, 2. Okay, so this will be the endpoints of the latus rectum. Now, before we graph, I would like to present na rin yung second one. Y squared is equal to negative 4x. By observing, we can deduce that the equation represents a parabola that opens to the left. Okay, with vertex at 0, 0. Now, the coordinates of the focus. Since we are going to, or it is given that the parabola opens to the left by observing, no, in its vertex at 0, 0, we will be using the fourth one. As mentioned here, if the parabola opens to the left, focus is located at h minus a k. So, but before that, I almost forgot, no, we do not know yet the value of a. To find the value of a, we have here negative 4a. Since in our problem, or in our equation, we have y squared is equal to negative 4ax. We need to say negative 4a is equal to negative 4 in this case. And In our discussion, as I have said before, uh, I do not want or we do not want a negative value for A. Though in some books, it is allowed for A to have negative values, and in some books, they are using another variable such as P or C. But in our discussion, we just use A. And A here, okay, this A here, since it is a distance, or it is, yes, it is a distance, we do not know or we do not want a negative value for this. So A here is equal to 1. Since A is equal to 1 and we will be using the fourth one, we have here 0 minus 1, 0. And we all know that 0 minus 1, 0 is negative 1, 0. Meaning to say the focus is located at negative 1, 0. Okay? For the next one, we have the directrix. Again, let V with the coordinate HK be the vertex of the parabola. The equation of the directrix is given by, again, we are going to use the fourth one since the parabola opens to the left. And so we have x equals h plus a. H is 0, a plus 1. So we have this equation as x equals 0 plus 1 or x equals 1. We also have this. Okay, so I just write it there, no? At the top. Axis of symmetry. An axis of symmetry is a line that contains the vertex and the focus of the parabola. Its equation is given by x equals h if the parabola opens upward or downward, and y equals k if the parabola opens to the left or to the right. Obviously, we're going to use the second one. Why? Because uh, the parabola opens to the left, as I have mentioned a while ago. So we have y equals k, and k is 0. So we have the axis of symmetry, or the equation of axis of symmetry at y equals 0. Okay, I just put it there. Now, the latus rectum, again, we will be using the fourth one because the parabola opens to the left. So here's the formula, and then substitution. 0 minus 1 will be negative 1. 0 plus 2 times 1, it will be 2. 0 minus 1 is negative 1, and 0 minus 2 times 1 is negative 2. So we have here negative 1, 2, and negative 1, negative 2. And graphing it will be, so for graphing, we need, or the first step that we need to do is to plot the vertex, focus, and the endpoints of the latus rectum. Okay? In this case, we have here I have here a Cartesian plane, and those points are, yan, V is located at the center, focus at located at 0, 2, L sub 1 located at the right, and L sub 2 is located at the left. Now, draw the axis of symmetry x equals 0, which is the y-axis. The latus rectum, we just have to connect the endpoints of the latus rectum for here, no? Or for this. And the directrix y equals negative 2. So the directrix denoted by D, as you can see on the line or the label below. Okay. The y-axis, x equals 0, and the endpoints of the latus rectum is the line that connects this, or the latus rectum is this line that passes through the focus and uh, perpendicular to the axis of symmetry. After doing so, draw a smooth curve passing through the vertex and the endpoints of the latus rectum. That will make our parabola. So that is for the step, for our step 3. And here we have the parabola, x squared equals 8y, that opens upward. For our second equation, we have y squared equals negative 4x. Plot the vertex 0, 0, focus negative 1, 0, and the endpoints of the latus rectum. Now we have here this, and the vertex, focus, L sub 1 and L sub 2. Draw the axis of symmetry, y equals 0, or the x-axis, the latus rectum, and the directrix, x equals 1. So directrix is this vertical line. Okay, the latus rectum is this vertical line segment, and the axis of symmetry is this horizontal or the x-axis. And as we can, or if we're going to recall, no, our parabola opens to the left. So we have here, yeah. So this is our parabola whose equation, standard equation, is y squared equals negative 4x. And that is all for the first part of the discussion in parabola.